is, in this class, we are going to start using a new notation for writing our answers. You guys are used to writing things like 2 is less than or equal to x is less than 5. We are going to switch gears and start using what's called interval notation, which is kind of the standard notation used for everything above Algebra 2. So in interval notation, what you want to remember is we will put a starting point, a comma, and your ending point. Okay, you don't have to have the x in the middle. We always have to go in order, small to large. So if it starts at 2 and ends at 5, then we would have a 2, comma 5. Now, the other thing we see in interval notation is parentheses versus brackets. When you see a parenthesis, that means not equal to. And when you see a bracket, it means equal to. So if I had said 2 is less than or equal to x is less than 5, we can equal the 2, so the 2 would get a bracket. We're ending at 5. Can I equal 5? No, so it gets a parenthesis. Okay, so it'll always look like this, a starting and a stopping. The thing that's different is whether you have the parenthesis or the bracket. We might have 2 parentheses, we might have 2 brackets, we might have 1 of each. So we're going to start today with just taking some inequalities and first writing them in that interval notation. I don't know what happened to my... Interesting. Okay, so the first one, I have 1 is less than or equal to x is less than 3. So, I have no idea why these keep moving when I click off the text box. But if I wanted to write this, we're starting at 1, comma, we're ending at 3. You can equal the 1, so it gets, and you can't equal 3, so it gets parentheses. Okay, second one, x is less than or equal to 1. All right, here's what's different. We have to have a starting and a stopping. If you think about on a number line, less than or equal to 1 is starting at 1 and going forever in the negative direction, right? So if I'm going to put my starting point, do we have an actual number where we're beginning when we go left to right? No. What we use is positive or negative infinity to show that it keeps going. So this is going forever in the negative direction, so it's coming from negative infinity. Now in infinity, it's like a sideways 8, okay? It's like that. We have a negative infinity, or just draw 2 circles next to each other. You can't make the infinity symbol. Infinity is not an actual number. You can't equal infinity, so anytime you have an infinity, it has a parenthesis. Okay, then when I graph this, it would stop at 1. Would 1 have a parenthesis or a bracket? Bracket, because we said the less than or equal. Next one I had on here. X is greater than 5. So if I were going to graph that, that would start at 5 and go forever in the positive direction. When you do your interval notation, it's small to large, so left to right on the number line. So coming from the left, the first number is 5. We don't equal 5, so it gets parentheses. parenthesis, comma, does this ever stop? No. So that is positive infinity. And infinities always have a parenthesis, no brackets. All right. What if I said all real numbers? All real numbers is talking about everything on the number line, right? So as you're coming from the left, because we have to go small to large, where is this coming from? And then it also goes forever in the positive direction, so that's positive. And infinities always get parentheses. So all real numbers, negative infinity to infinity is maybe a little more time consuming to write, but in general this is kind of a time saver. Especially when we get into like domains and ranges, we don't have to specify whether we're talking about X or Y, so it is a little bit nicer. Let's go the other way. I'm going to give you an interval notation, and I want to see if we know what I'm talking about. So I want to write the inequality that goes with it. It can be helpful to draw a number line. When we start solving these, I will ask you to graph your numbers on a number line. We will, in the past, you've used open versus closed circles. We are going to keep our notation consistent. So instead of an open circle, I'm going to use a parenthesis. Instead of a closed circle, I will use a bracket. So the notation on my number line is the same as the notation that I'm writing it in. So this one has a bracket on the 1 and a parenthesis on the 4. It's just everything in between them. How would I write that as an inequality? Less than or equal to, because of the bracket, to x, which is less than 4. B, 2 to infinity. It's saying it starts at 2 and goes forever in the positive direction. So that means greater than 2. Negative infinity to negative 3. Negative 3 has a parenthesis. So that means everything's smaller than negative 3. So that's x is less than negative 3. Any questions for me about interval notation? So the rest of what I want to do today, we're just going to solve inequalities, and we will graph our final answer and write the interval notation for it. So here is our first one. We'll start out with just a nice linear inequality. How would I solve this? Just like solving an equation, the only thing you have to remember with inequalities, if you multiply or divide by a negative, what happens? Flips the sign, good. So I'll subtract over my x, add over my 1, divide by 2. 2 is positive, so my sign doesn't flip, so I just get x is greater than or equal to 2. For my purposes, if I ask you to graph this, I'm not going to make you don't have to draw me a nice perfect number line starting at 0 and going both ways. I just need a few points. We need to cover 2, so I'm just going to put a few points on my number line. We're doing a pretty rough sketch here. All right, Equal to would mean parenthesis or a bracket. Bracket. Your brackets and parentheses have to face the direction you're shaping this going. So we want greater than or equal to 2. So that's starting at 2 and going to the right. Some people like to draw it above their number line. I don't care which one you do. Whatever, as long as I can see what your graph is. So my interval notation, if I do that, we just go left to right, small to large. So it starts at 2. My 2 had a bracket, comma, kept going forever, so it stopped at infinity, and infinity always gets a parenthesis. Let's look at this one. Alright, this is a compound inequality. So basically just like an equation, but if you do it to one piece, you have to do it to all 3. So if I'm trying to solve for x, what would we need to do first? And if I'm going to take the middle times 4, we have to do both ends times 4. We get negative 12 is less than 2x minus 1 is less than 0. Then we would have to add 1 to everything. And divide by 2. So I have negative 11 halves is less than x is less than 1 half. So your number line, you need to do a rough sketch. Negative 11 halves, that's like negative 5.5 to positive 1 half. Space those out, put your tick marks in between, but you don't necessarily have to extend your number line all the way to positive 5. So we are just in between those, both get parentheses. Yes? Oh, yeah, I stopped mine at negative 1 half instead of positive 1 half, didn't I? Thank you. Alright, so interval notation going left to right, parenthesis, it starts at negative 11 halves, comma, ends at positive 1 half. So far, so good? Alright, if I'm trying to solve for x, what's the first step? Negative 10 is less than negative 2x. Is less than or equal to negative 9. What will happen when I divide by a negative 2? Good. So I get 5 is greater than x is greater than or equal to 9 over 2, or 4.5. Okay, so if you were graphing this, you don't have to draw a full number line for me, but just a rough one. So this x is between 5 and 9/2, which is 4.5. We have the equal to on the 4.5, not on the 5. So the graph would look like that. Interval notation, you have to go left to right, small to large. So it would be 9/2, comma, 5. So as long as it divides evenly, so 4.5 would be fine. If it were a 1/3, I want you to keep 1/3, not write 0.3. Other questions? So the next bit, I want to look at a quadratic inequality. So we're going to talk about a couple different ways of solving these. If you don't have a graphing calculator, you need to grab one. Okay. So this is a quadratic inequality. If I asked you to solve a quadratic equation, what would you do first? Okay. So we get it equal to 0, and then what would you try? See if we can factor this thing. This one we can do box method. So x squared breaks into x. Multiply to -12 and add to -1. -4 and +3. Okay, here's where it's different though. So just sit back and watch for a second. Don't write this down. People always want to just jump and say then each one of these things has to be less than 0. Here's the problem. If these are both less than 0, then they're both negative. If you multiply two negative numbers, what do you get? A positive. And is a positive going to be less than 0? No. The only way this will be less than 0 or negative is when one of these things is positive and one of them is negative. So I'm going to show you two ways to figure out when that happens. The first way is by using a graph. I'm going to draw a really rough number line here. And what I want to put on here is what makes each of these parentheses equal 0. So what makes x minus 4 equal 0? And what makes x plus 3 equal 0? Okay, you have to put the smaller number on the left. So those are the only two numbers I'm putting on this number line right now. I want you to get your calculator and I want to graph the x squared minus x minus 12. So you go to your y equals x squared minus x minus 12. If your window is funny, do you guys remember how to reset that? Go to Zoom, number 6. So everybody try this on your calculator. Raise your hand if you can't get this graph. So I just plotted my original, the x squared minus x minus 12. Zoom number 6 if your window is funny. The 2 points I have plotted on my number line are -3 and 4. What does that correspond to on this graph? The zeros, the x-intercepts. Here's -3 and here's +4. So it's the 2 places where my graph hit the x-axis where it was equal to 0. Alright. Before you get to -3, so I'm talking on this section of the graph, are you above or below the x-axis? Above, right? So that means that all of these values are positive before I get to -3. Above the axis is positive. Between -3 and 4, what's happening to my y values? Yeah, they're negative. They drop below the axis. So that's where they are negative. After 4, what happened to my values? Went back up, they're above the x-axis, so that is positive. Did we want positives or negatives? I said less than 0. Less than is negative. Not equal to, so we're talking parentheses. So the portion of my graph that worked was this negative part. And again, that's because I wanted less than. So we are just looking between here. So my answer is -3 to 4. I can pick any number between -3 and 4, and it makes the original inequality true. Your textbook, if you look, they talk about another way of doing this, which is kind of the same, except instead of looking at a graph, they just pick numbers. So you can sit back and watch, and after I do both ways, you guys tell me what you like, okay? So we start out completely the same. We factor it, and I get my number line. I have my -3 and my 4. This is the point where we picked up our calculator and looked at the graph. The other option is to just pick a value for x. It has to be something smaller than -3. So maybe -4. We will need something in between -3 and 4. So maybe 0. And then something bigger than 5. Or bigger than 4, excuse me, like 5. So I just picked a number that fit each in. Then you can plug these numbers in. I don't care about the number, I just care if it's positive or negative. If I do -4 minus 4, that would be positive or negative? Negative. -4 plus 3 is negative. What happens if you take a negative times a negative? It becomes positive. Didn't we say that was positive by looking at the graph as well? So if we plugged in 0, 0 minus 4 is negative. 0 plus 3 is positive. If you take a negative times positive, it becomes negative. If you plug in 5, 5 minus 4 is positive. 5 plus 3 is positive. Positive times positive is positive. So we wanted the less than 0 still. We get the same answer. So how many of you like the looking at a graph? Okay, does anybody prefer the plugging in numbers? Alright, so either one works. I will probably talk through both ways, at least the first few problems, just to give everybody those options. Alright, let's look at another one. What's my first step? Set equal to 0, and we're there, so then we go to box method. So x squared breaks into x, multiply -15 and add to -2. Once I get my parentheses, on my number line I put the two things that make it 0. So what would make an x minus 5 equal 0? Positive 5, and x plus 3 equals 0 will give me -3. Make sure you put the smaller one on the left. Okay, I'm going to talk through the picking points first. If you want to go ahead and do it by graphing, you can graph it and then we'll compare answers. less than -3. So that might be like a -4. In between -3 and 5, so maybe a 0. And then bigger than 5, maybe a 6. If I plug in -4, -4 minus 5 is negative, -4 plus 3 is negative, negative times negative is positive. If I plug in a 0, 0 minus 5 is negative, 0 plus 3 is positive, negative times positive is negative. I plug in a 6, 6 minus 5 is positive, 6 plus 3 is positive, positive times positive is positive. If you graph it, what was our original? X squared minus 2x plus 5. No, minus 15. Alright, so we can see before the -3 it's greater than 0 because it's positive. In between it's less than, so it's negative. After it's above again, so positive. Which answers did I want? Greater than means positive. So that's all of this and all of that. So to write this in interval notation, we have to describe both of these pieces. This one's going off in the negative direction. So it's coming from negative infinity, stopping at -3. This one picks up what we do if we have more than one piece. You put a U in the middle, it stands for union. Then the next one starts at 5 and goes in the positive direction. No, because we don't have an equal to right here. So the only way we would have a bracket is if this was an equal to and then both the -3 and the 5 would have brackets. Okay, other questions? Yes. From the portion of my graph that was positive. If it went in the middle, we would hit the negative part, and I wanted greater than 0, not less than 0. So I wanted when the graph was above the axis, which was both ends. Other questions? Okay, we are stopping here today. So, not giving you any of the quadratics on your homework tonight. We're picking up with the quadratics tomorrow. So this assignment, I'm going to add to it tomorrow, and then we'll turn it all in on Monday. The first 10 are matching questions, and then you've got some linear